at the same time, the cost of doing this online, centralized, very expensive system called timesharing basically meant that GE had to charge too much. All the companies took a look at their timesharing bill because everybody was using it, and they stopped timesharing. So students still learn BASIC. They learned how to use it, they learned how to write programs in it, but after they left school, they couldn't use it. When I went back to Phoenix from my job in Ohio, I sat down and we were designing a cash register system. And the cash register system at the time I went there was a very online cash register system. You hit a key, it had to go all the way to a central site, come back and tell you what the key was. There was no local storage, no local intelligence. I'll tell you what happened to that in a minute. I looked at that and a bunch of other things that kind of have been in my head and just developed the concept of distributed intelligence. Changed my life again. I've been working on distributed intelligence ever since. When I was at Phoenix, a guy by the name of Bob Schrader, you're going to hear his name 2 or 3 more times, right, took me to Fairchild and showed me what Fairchild could do with custom silicon. So we developed a theory inside the company with me and several other people that we could build intelligent cash registers, we could build intelligent credit verification with the intelligence in the device. And we were going against the established party line, which was said that everything is online computing. Well, a funny thing happened. They put pennies online, and they put every cash register in Penny's stores in Orange County online as a test case. And somebody ran a car into a telephone pole outside the central processing area. And in every store that Penny's had in Orange County that day, which was the day after Thanksgiving, they could not sell anything. So that was kind of the end of online cash registers, right? Which should have happened. It wouldn't have gone away as fast if we hadn't had that fiasco. But we were right. We were right that distributed intelligence was going to work. One other thing was going on at the same time, and I'm going to try. I really will tie these all together in a couple minutes. At GE, they had developed a pretty fast multitasking system with the ability to do a significant amount of communications. Dr. Joe Weizenbaum, who I met back in the computer lab, had gone to MIT, and he developed a theory that says if I give a programmer total space, right? He doesn't have any limitations in his code, doesn't have any limitation in his data size. I will be able to develop programs that work better, faster. And so he got MIT to fund a program called Project Mac, which, by the way, any of you that have been through MIT, you're still there. It's still Multex. It was revolutionary. Because what he did was to show he was correct, that with that kind of resource, a programmer could do anything. And the idea was very expensive online system. It was so expensive, and Multex was relatively complex operating system, that I'm going to forget I had it just a second ago. Guys that work for Bell Telephone, Western Electric, I think it was. Anyhow, at that lab for Bell, these guys took a look and said, this is a great system, but we can't afford to keep using it, it's too expensive. So they took a mini computer from DEC and they wrote a program that was a subset of Multex, which all of you know is Unix. Now the word Unix, if you think about it, doesn't mean multitasking 35 million people using the same computer. These guys actually did intend it to be a simple one-person machine, but of course they put all the stuff over from Multex, which meant they could do multitasking. They also, along the way, invented C. Okay? So what we had was a real proof that giving a programmer or giving individuals enough compute power that belonged to them that we could do a better product. Okay, I left GE to build cash registers, automated gas pumps, and credit verification systems in 1970. It was a great concept. We actually built a demo unit using as a memory national shift registers because there weren't any memories, right? And I made it work and I showed it to everybody. And they said, well, what can you build it for? And we did some calculation, and without going to silicon, we couldn't do it. So we didn't have the money to go do 6 custom silicon devices, and I had to have a building block. So I went to work for a guy at Motorola who made the 6800 happen. He was a calculator guy. He said, I believe the world needs a microprocessor. And everybody else said, what's a microprocessor? And what he defined it as was kind of a super calculator, but he knew it really shouldn't be. So he said to me, he hired me, saying, look, you already know what you want. Go make it happen. And they gave me a chance to do that. We developed the programmable I/O device, several changes to the structure of the 6800 that made it a product that we ultimately sold to a whole lot of people, right? Ultimately, Motorola got to put all their microprocessors into cars and everything else, which was all the work we did. But the problem was that Motorola marketing guys thought what we had built was a replacement for the mini computer. Now, mini computers at that time were going for $700-800 minimum, and by the time we built them up, they were starting to grow big because of Unix. And so these guys said, well, I got a $300 mini computer, that's what the world needs. Okay? Now, I did a class at Motorola because nobody else understood microprocessors except me. Sorry to say, I'm not trying to brag about it, just literally everybody that was in designing microprocessors at that time, Intel, every place else, came from a calculator background. They didn't understand what you did with a microprocessor. So I did a class for the application guys, and in the class, the guy who was on sabbatical from Iowa State, by the name of Roger Camp. Dr. Roger Camp helped me change the world, and you're going to see how as we go through this thing. Right? When I had to go out and do all the applications support for Motorola, because again, I was the only guy who understood what they did. So when I would meet with customers, we'd go through this discussion about the 6800 and how wonderful, and they'd fall in love with our I/O devices, and then they would say, your processor's too expensive. So what I would do is I would sit down at a blackboard, and we would write down the minimum instruction set, and they wanted a $25 microprocessor. Well, Motorola marketing guys found out I was doing it, and they got Motorola to give me a memo that says, stop. And I wrote them back a memo that says, guys, the minute you told me to stop, you gave me the rights to everything I've worked on. I don't care what your patent agreement would be says. When you abandon a product, it belongs to me.
Small problem with the sound here.
Right?
Hello? He won't be able to. Hello?
Brian, can you hear me?
Okay.
Hello?
I think you're better now. There was a hiccup. I think it's worse.
This used to happen to us at CS shows all the time. This is just...
Sometimes you had a can of freeze spray that would help.
Yeah. Die for the reset button.
Escort the marketing person away from the prototype.
Well, it's
Blame it on Atari.
We're good. Just one building
I'm back.
here.
Can you guys hear me now?
Yes.
Yes, you sound good now.
There we go.
Okay. I'll turn my video off again. I'm not doing anything obscene while I don't have my video on, am I?
No, you're looking good.
Okay, good. I've got to punch his nose because I said I want to get all these names because they really are people who made major contributions, most of whom were totally ignored. Okay?
Well,
Anyhow,
you ended right about talking about 6800. Talking about
no, I'm going to talk about what we were doing next. They threw me out of Motorola, basically, right? I've been thrown out a lot of better places. Through a series of flukes, I discovered that the engineer who did the very first magnetic ink character recognition system, who I worked for at GE for a little while, was now doing high-end calculators, semiconductors in Pennsylvania. And I talked to 2 or 3 other semiconductor companies. I had to have a semiconductor company that was going to go do this, and most of them were afraid of Motorola. But when I explained to him, because he's a computer guy, when I told him what I wanted to do and how I wanted to do it and why it made sense, he understood it. His name was John Pavinen, and he made almost everything that we're going to talk about afterwards possible because he backed us, right? And he ultimately got sued by Motorola. It cost him his company. But he understood and he backed me. We took a design team from Motorola and moved to Pennsylvania. If you mind, I'm going to tell you the guys' names because, again, only one of them stayed famous. Bill Minch, who is the head of the Western Design Center, who did the 816 for Apple, who did the 816 for all of the video games, is still the guru of 6502. And, you know, he kept it going when the rest of us walked away. So, more power to him, and I'm working with him now on new design, actually. A guy named Rod Orville, who was one of the key designers of 6800, did the architecture with that, decided he'd rather live in the West than Pennsylvania, took off, and we've never heard from him again. Another guy by the name of Ray Hurd, who was more of a process guy, went back to Arizona working for another company. A guy by the name of Will Mathis, who had joined us at Motorola and who was an alternate architecture. He'd actually designed the controller for the bank systems where you could put your money in and it would give you credit, you know, the beginning of the automated teller system. And Will and I were the 2 that did the logic for the 6800, and Bill and the other guys did the circuit design and the internal architecture. Will wound up working for DEC, and then I think he just went back to Pennsylvania, and I have not heard from him since. If he was in the audience today, I'd love to hear from him again. One of my favorite people at one time. We had 2 layout guys, a guy named Harry Bauckham, who was a little crazy, not a little crazy, a lot of crazy, and a guy named Mike James, who cost us a lot of trouble, but was a really good layout guy. Took a process guy, Terry Holt, and John Pavinen, and John developed a new 5-volt process in the same amount of time we took to develop a microprocessor. Nowadays, if you ask somebody to design a new process, they talk about $500 million and 5 million people. John and Terry did it effectively by themselves with a couple other people.
I do that.
We did the 6502, the VIA, and the combo chip in 9 months. One of the things about Bill Minch is he's never built a chip that didn't work the first time. Just a phenomenal guy when it comes to getting the layout to work. There's some wonderful pictures, which I couldn't get my hands on to ship around, of what we had to do the layout. We actually drew these pictures on walls. We had one entire room with the 6502 on it. No simulation, none of this wonderful layout tools you have today, all in my hand. Okay? Because we knew what people wanted in a cheap micro, but also the tools, we developed a cross-compiler with a guy by the name of Mike Porter, who was my first contact from Dr. Roger Camp. Mike did the cross-compiler for us, and then later on did a lot of wonderful things with me at my following companies. We did an online simulation system called TIM1 with some people in California. And based on a very creative idea, because they were calculator guys, by Don McLaughlin, who was the engineering manager, and Bob Walterhofer, who was the programming manager, it was their idea that created the KIM-1. The KIM-1 became almost like a standard for people who wanted to learn about microprocessors. You really couldn't do much with it, but it really and truly was an introductory product. It was on one board, you could buy it, it worked, it was a wonderful idea. More power to those guys, and you probably never even heard their names, but now you heard them. It's their idea. It wasn't mine. We carried it forward, but it was done by that team, which was part of the team at M1 Technology. We joined it. We introduced the 6502 at a component show in San Francisco, and we'd taken an advertisement in the paper about 2 weeks before saying, come to this show, we'll sell you a microprocessor for $25. And I remember that number came out of all that research we'd done, and we wanted to sell them. We could sell one for $25 because we wanted to imply, which we ultimately did, we could sell it a lot cheaper. But the most important idea was we had it. We weren't just talking about futures. We had it. You could come by the show and buy it. 2 days before the show opened, the show guys caught on to what we were trying to do and said, no, you can't do this. You're not allowed to sell anything on the floor. You're bad guys. What are you trying to do, ruin our show? And so we said, okay. So we took a suite at the St. Francis Hotel, called the MacArthur Suite. And if you went by our booth at the show, we said, take the bus over to the MacArthur Suite. Well, there were so many people packed around our booth that wanted to go to the show that ultimately people would get on the bus and says, is this the bus to the MacArthur Suite? I mean, these people came in, we'd laid this room up really nice. You could see the Kim 1, you could see our layout, you could see the Tim, all this sort of thing. There are 2 books that were there, and I'm going to tell you a little story about how we wrote the books. That were really quite well received were there. And sitting at the table was my beautiful wife with a barrel full of microprocessors. And if you wanted to buy a microprocessor, she'd reach in the barrel and sell you one for $25, and then you could buy $10 each for the books that we had. And you could buy Kim 1. We had some Kim 1s for sale. Ultimately, only a few sold that day. A whole bunch sold right after that. And the story about the barrel was the top 10% of the barrel had working microprocessors in it. The rest were really impressive. Okay, then we had a barrel of microprocessors. We had a very famous guy come by and buy something out of the barrel. The guy's name was Steve Jobs. He took his processor back to Woz and they created Apple. A side story, and I'm going to tell you about this guy in a second because he's a really important guy along the way. My West Coast manager talked to the Apple guys who were having trouble bringing the original Apple 1 out. I had this development system that weighed 550 pounds. They used to carry around, and it had a little teletype printer hooked to it. And we took it out to the garage, and we hooked it up, and we showed them what they were doing wrong, helped them develop the program. So actually, Peter and I helped bring up the Apple 1. We'll never get credit for that. And no, do we really want one? It was because they were just another customer. Right after this show, if you don't mind, I'm going to deviate. I was just going to do something else next, but I'm going to deviate for a second. Remember I told you about these 2 books? Well, I had a guy work for me in Phoenix who had escaped from Czechoslovakia. And he was brilliant. In fact, I had 4 Czechoslovakians that were brilliant that had all escaped from Czechoslovakia. And Peter and I formed a lifetime relationship. Peter was working for somebody else. I talked to him about joining us at M1 Technology to help me be my West Coast guy because he was very skilled about computers, good application guy, a very pleasant guy, and knew how to sell because he'd actually worked for, I think it was Bechtel at the time. Peter was brought back to help us write these books, and he started writing the books with me, and I had to write a lot of it. And I was busy. I was doing the marketing. I was helping finish the engineering and everything else. So Peter went to John Pavin one day and said, if you don't throw Chuck out of the building and make him stay home until we finish these books, we're not going to have the books done on time. So John, being the wonderful person he was, he called me in his office. He said, I've told the guards you're not allowed in the building. Go home and write the damn books. Well, thanks to Peter, the books were very well received. And I did stay home and write them because John meant it. He wouldn't let me in his building. Nice story. Peter was the guy that actually supported Apple, and another very famous customer. When I was developing, when we had announced the C502 was in the paper and everything, but we hadn't actually done the show yet, we started getting all these people sending emails and making phone calls, and I would look through the list and say, well, I'm not going to bother calling us back. We'll see them at the show. And there was this one from a place called Grass Valley, California. Those of you that know California know it's a beautiful, wonderful place, but it's not the sort of place you expect to have a high-tech question coming through. So I got on the phone with the guy and discovered that that was the research park for Atari. So right after the show, we went up to Grass Valley. We met with these guys, and out of that came the decision that ultimately created the programmable game. Because this guy could see that with the microprocessor and the combo chip, he only needed one more chip to make the programmable game. Now, just before the show, we had brought on a company called Synertech, and this is the final tie to my buddy Bob Schreiner. Schreiner had left Fairchild along with all of the other people at Fairchild and started Intel and all these other things, and he wanted to start his own semiconductor company, so we got Honeywell to invest in him, and he started a semiconductor company, but he was doing kind of mediocre. But he knew me and John real well, and so we went to him and said, look, we need a second source before we introduce, because Motorola didn't have a second source and Intel didn't have a second source, and we wanted to be second source so people would use our product. So Schreiner said, yeah, sure, I'll be happy to do that. Well, it turns out it was very important to him, because Atari said, we don't want to get caught up with an East Coast company doing development. They took two guys, one of whom, Jay, went on to do the, come on, all of you know the name of it. Somebody help me. The follow-on product that Jack Tramiel sold. I mean, the Commodore sold.
Amiga?
The Amiga. Thank you. Jay's name's hard enough, Amiga, right? Anyhow, Jay sat down and did the design for the chip for Atari. And the combination of three chips, we introduced the thing. 1 week after Atari introduced our product, Motorola sued us because they were mad. Anyhow, Schreiner designed the video chip. We provided them with micro and the combo chip and created the programmable game market. All right. At this point, we're at MS Technology. We have a great future because, Atari's coming down the road. But the company was having trouble because this is a period of time when calculators started to die in the United States because the Japanese had brought in CMOS calculators. And the guys at MS Technology basically said, look, we can't really fund the bridge. So we're going to start selling Kim 1s, which we did, which helped from a cash standpoint. But I had to go out on the road and start designing customer applications that would come in faster than Atari. Well, two of the places that I went to, one place in Florida, and two key things happened there. One, I was designing a copier, which was fun. I did that in about a week and a half. And then I was sitting at this place in Hialeah, working around the clock, designing an electronic pinball game, which was, again, a lot of fun. We did finish it, we put in shows, everybody thought it was wonderful. And ultimately, of course, all pinball games use microprocessors. Well, in the company, there was a guy who had been a musician. He followed the music guys around. He was a musician. He was a guy that went and did the sound stuff, and he had this long ponytail, and he wore shorts all the time. And he was getting busted all the time because he was a blue boxer. Okay, so he got busted for being a blue box. He got busted because he looked like a hippie. But he was really good at sound. So these guys had them sitting in his company designing the sounds for these games, which, if any of you are old enough, you'd recall that if you went to an arcade, you were really dealing with an electromechanical device that made noise more often than you were dealing with video stuff. So that's what he did. Well, so he would work at night, and I'm going to deviate for just a second. The last thing I did on my way back from the announcing 65.2 was stop in Colorado with a company called, the guy's name I remember is Dr. Sooty. I don't really remember the name of the company. And what he was doing was taking chips, at that time he was taking the Intel chip. He ultimately used the C80, and he was building one at a time kits that people then put together to make their own computer. And he was doing very well. And we talked to him, and he was going to start using our product and everything else. So I at least knew him. Well, this guy with the ponytail is sitting in the same lab where I'm developing this pinball game, and he's putting together this kit. He gets a kit put together, plugs it in, says it works. And he could sit there, and I think he had a paper tape or something or other, and he took a stolen copy of Bill Gates' Basic, and he put it in, and he did a couple things. And then he said, well, okay, that's it, I'm done. And so I talked to him, I said, well, you just built yourself a computer, what do you want to do with it? He says, well, no, I wanted to build a computer, okay? But I'd like to do something with it, but I don't know how. Right? I'm figuring out what to do with it, because it doesn't do very much, right? And so he was the personal impetus that drove me to do the PET. Because he was a guy, really brilliant guy, he brought up his own computer, and all he was interested in was being a hobbyist, right? Well, I knew the Apple guys, they were selling hobbies. It was a small market for people, but I started doing some quick market research, just talking to people as I was going around talking about microprocessor. And everybody who was a programmer, or everybody who was an accountant, or everybody that was doing all of the other things said, I can't make a kid computer. And when I do, it doesn't work very well. I don't want to do that. So it became really obvious that I had to stop working on my cash register and stop working on my credit verification system. And I had to build a computer that did what those people said they wanted. And it was real easy because they all had a simple description. They wanted something that's got a video screen. My friend Larry Hiddle went off and put monitors in everybody's life. So most of these people had seen a computer with a monitor. They wanted a monitor, they wanted a keyboard, they wanted BASIC. Okay? And at that time, they wanted something that was better than paper tape. It was an easy spec. Okay? So I talked to the guy that I was dealing with in Florida, and we thought we might go off and do something with him. About that time, Commodore was a calculator company. It had been through terrible problems in Canada. A guy by the name of Irving Gould had bought the company off the street. Irving was a real aficionado for Japan, and should have wanted to put a Japanese girlfriend forever. And he came to Trammell and he said, Trammell was making mechanical calculators, and he's making them in Germany and everything else, and he said, forget it, just forget it.